Okay, so this is going to be a quick video. This is 112 Simpson's paradox. So we're actually only going to look at one problem, kind of break it down and talk about it. So if you read through the problem, you have 3 baseball players and they're each hitting 300 going into the last day of the season. On the last game, one of them goes 3 for 5, another goes 4 for 5, and another goes a perfect 5 for 5. And then it tells us how many at-bats they've had during the regular season. So as you can see, they've had dramatically different number of at-bats throughout the entire season. So it's just asking who would end in the highest batting average by the end of the season, or after the game, because it's the end of the season. So we have Joe, Bo, and Mo. So they're all hitting 300 and tells us respectively how many at-bats that they've had. And then we need to add on the final day to them. So we need to figure out how many hits they've had during the entire year. So we're going to kind of set an equation of X over the number of at-bats that they've had equals their batting average. So if you remember, batting average, which is BA, is hits over at-bats. We know the batting average, we know the at-bats, we don't know how many hits. So we need to figure that out for each one of them. So I'm going to go X over 420 equals 0.3, and then X over 60 equals 0.3. To figure out how many hits that they had, it's pretty easy. All we need to do is just multiply our numbers here to get X by itself. And we're going to see with Joe, during the course of the season, he had 72 hits on his 240 at-bats. We have Bo had 120 over 420 at-bats. And then we had Mo with 180 hits over his 600. So before we go and do our problem here, before we get our final answer, we need to add in, so I know this isn't mathematically correct, because if we're talking about fractions, I would have to get a common denominator and all that fun stuff. But in the case of this problem, I'm adding on 3 hits, 5 at-bats, 4 hits, 5 at-bats, and so on to each one of these. So if we just kind of look at this problem from a logic standpoint and think about it, we have 3 batters here. They all have the same batting average. We see that Mo, he had a perfect game. So if they have the same batting average, Mo had a perfect game where he didn't not get a hit. It would make sense that he'd have the highest batting average, right? And then it would make sense if Bo was at the second highest, and then Joe would have the smallest batting average because he only had 3 hits. So let's actually go through and do the math and check to see, because logically it makes sense that if Mo had the most, but let's do the math and see exactly how it comes out. So I'm adding 3 hits, that's 72, so it's going to be 75 over 245. I'm going to have 224, or 124 I should say, then 185. So you can go through and plug each one of these fractions into your calculator to get a decimal. And because they're close together, we're going to go to 4 decimal places. So if you type in Joe's, which is 75 over 245, you're going to see you're going to get 0.3061. So his batting average is 0.3. He gets a few more percentage points from there. So then we go and type in Bo's, and we would think we'd get a number bigger, but we don't. We actually get 0.059, and then Mo, the one that we logically would think would have the highest batting average, he actually has the smallest by not 10th, that'd be what, 1,000th, 100,000th right there. So it turns out that Joe has the highest batting average, but he had the least amount of hits in the last game. Well, this is the Simpson's paradox at work. Essentially what it is that because originally Joe came in with the smallest number of at-bats compared to the others, especially compared to Mo, him getting a hit percentage-wise means more based on his small population. But this is a paradox that happens all through statistics. So this is the only question, like I said, in it. The next one just wants you to kind of do some research on it, but it's good to be aware of the Simpsons paradox. If we have 2 wildly different populations like we do here, the meaning of the hits in this scenario means more for Joe from a percentage standpoint because he's had a smaller population size compared to Mo, who's had a lot more. So that's Simpson's paradox. It's something that pops up a lot throughout statistics, and one of those things that's good to be aware of. So short little lesson here just to kind of go over essentially what Simpson's paradox is. If you're interested, you can definitely do some more research and find some more examples of this in the real world.